Okay, hi guys. So in the previous lecture, we were seeing the hydrolysis of ethyl acetate, which is given that it is a pseudo first order reaction, and the reaction is as follows. And we saw that the initial concentration, we assumed that it was A, and the initial concentration of acetic acid and ethyl alcohol was 0. Then at time t, it was A minus X, and they both were X. And concentration after a long time, or at t equals to infinity, we can see that whole of CH3CO C2H5 is not present, and it got completely converted into products. So now we'll be seeing what is known as the reaction progress in terms of volume of NaOH. So we'll be seeing reaction progress in terms of volume of NaOH. So this brings us to the point of acid base titration again, in which NaOH acts as a base and CH3 C double bond OH, which is acetic acid, acts as a H plus donor in the reaction mixture. So at equivalence point, what can we say is that N1V1 would be equals to N2V2, where N1V1 is the concentration of the molarity into N times V1. This M is the concentration of the acid present in the mixture, and N2V2 is the volume of NaOH used in the titration. So from here we can see that volume of NaOH needed is directly proportional to the concentration of acid. Okay, so in the initial phase, I hope you have noticed that we have also used H plus as a catalyst in the mixture. So when we are initially reacting or titrating NaOH with the solution, we would be getting, or rather at equivalence point, only the H plus from the catalyst would be participating in the acid base titration with NaOH. Okay, and after time t, when the ethyl acetate got converted into acetic acid, then it would be titrating with the H plus from the catalyst, and plus at time t we saw that X concentration of CH3COOH is also present in the mixture, and as a result CH3COOH gets dissociated into CH3CO minus plus H plus. So this H plus, the concentration of this H plus has to also be added in the titration or in the acid base titration at equivalence point. Okay, and at V infinity we can say that concentration of H plus from the catalyst plus at infinity whole of CH3COH would be getting converted, or other whole of CH3CO C2H5 would be getting converted into CH3COH, and as a result, if A moles of, or A is the concentration of CH3COH present, then the same concentration of H plus would also be there, because it dissociates into CH3CO minus plus H plus. So this would be the case, or the volume of NaOH which would have been reacting at various stages or timelines of the reaction mixture. Okay, so we know that it's a pseudo first order reaction, so rate constant would be equals to again 1 upon T ln A upon A minus X. So from these three equations we can write that, or rather directly writing it in equation 2, that in equation 2 if we substitute the value of H plus, as the concentration of H plus is directly V0 is directly proportional to the concentration of H plus, I can write that Vt is proportional to V0 plus X, or X is proportional to Other Vt minus V naught is proportional to x. Similarly, for A, we can write that for denominator we want A minus x, so 3 minus 2 would give us A minus x on the right hand side, and this would give us V infinity minus Vt on the left hand side. Okay, and if we add these two equations 4 and 5, we would be getting right hand side as A, and on the left hand side we would be getting V infinity minus V naught. So putting these values in this equation, we would be getting K would be equals to 1 upon T ln what is A? A is V infinity minus V naught, and what is A minus x? A minus x is V infinity minus Vt. So this would be the K, or the rate constant, which we would be getting on having the acid base titration after the hydrolysis of ethyl acetate. So V naught was the volume of NaOH used to react with ethyl acetate and catalyst. Okay, Vt was the volume of NaOH reacted when the ethyl acetate got converted into acetic acid at some point of time, which is T. So volume of NaOH used when reacted with ethanoic acid at time T. And finally V infinity would be volume of NaOH used to react with ethanoic acid at time t equals to infinity. Okay, now let's see another topic, which is inversion of cane sugar. Or in other terms, we can also write this as hydrolysis of sucrose. Okay, so suppose we have C12H22O11 aqueous reacting with H2OL and forming C6H12O6 or glucose, again aqueous, plus C6H12O6 aqueous. So this is sucrose, and from sucrose we get glucose and fructose. Okay, so let's say the initial concentration of sucrose was A. This is in excess, so we are not counting this, and these two are not present in the mixture. Later concentration at time t, we can write that this would be A minus x, and these two would be, the concentration of these two would be x. And now concentration at t equals to infinity, we can write that concentration at t equals to infinity would be, this would be 0, not considering H2OL, and at t equals to infinity both glucose and fructose would be present at AA AA concentration each. And by the way, this is dextro sucrose. Okay, so now we would be seeing reaction progress in terms of angle of rotation. Okay, we would be seeing this part in the next lecture. So till then, good luck and goodbye.